This lesson will cover the topic of frontal mechanics. These are the terminal objectives, and here are the enabling objectives. This discussion will focus on the frontal systems themselves, including their formation, the flight conditions associated with them, and how that affects the aviator. First off, an air mass is a large body of air that has essentially uniform temperature and moisture throughout a horizontal plane. If you look at the graphics below and to the right, you will see that in certain areas the moisture or precipitation is either present or lacking, meaning that it's moist or not. And then we have areas that share roughly the same temperature. So those areas that share the same amount of moisture and the same equivalent temperatures make up your air masses. We name the air masses according to three things: not only the temperature and moisture content, but the location from where it comes. So the locations are either Arctic, which would be above 60 degrees north latitude, including the poles, and then below 60 degrees north latitude, but above 40 degrees north latitude is the polar region. And then we have tropical and equatorial to the south of the main body of the U.S., being the four regions. The middle region is not named because relative to us, that's here. Moisture content is either going to be maritime or continental, whether or not it started out over water or if it started out over land, and this contains less moisture. And then the temperature, warm or cold, is going to depend on the ground which it is over. If the mass of air has a temperature that is above the ground temperature, that is considered a warm air mass. And the opposite is true for a cold air mass. It is going to be air that is colder than the ground that it is over. So those are the three things we use to name air masses: location, moisture content, and temperature. Temperature also indicates stability. So warm equals stable, and cold equals unstable. And the reason is because warm air over cooler ground or colder ground will eventually cool down, and when air cools down, it tends to settle or remain where it's at. Cold air over warmer ground will eventually heat up and begin to rise, which makes it unstable. A frontal boundary is the boundary between two contrasting air masses. It's named according to the temperature change. So as the front passes from west to east, which is the way all major weather patterns move in the United States, whether it gets colder or warmer is how we determine whether it's a cold or warm front. The winds will always shift either 90 or 180 degrees on either side of the front, just depending on what type of front it is. They will always be parallel ahead and perpendicular behind, with the exception of the occluded and stationary fronts. All fronts are located in troughs of low pressure. In previous lessons, we saw the symbology for a low pressure trough as the dashed line. Oftentimes we see the front and not the dashed line because the front lies in the trough. That means that pressure will always fall and then rise as the front passes and be at its lowest point when the front is directly overhead that point on the ground. Fronts move perpendicular to their depicted line. So if the front is drawn from northwest to southeast, that means that it will move in a northeast direction. Cold fronts move faster than warm fronts, and the greatest contrast between air masses exists at the surface. The differences between those contrasting air masses begin to become less and less as we increase in altitude, and by the time we reach about 15 to 20,000 feet AGL, above ground level, the differences between the air masses is negligible. It is most pronounced at the surface. Here is a depiction of a frontal model, and it shows the general trend that fronts follow as they pass from west to east in the continuous United States. The way we locate and classify fronts is by the discontinuities between these next four items: temperature, dew point, pressure, and wind. The temperature we already talked about. So if you look to the right of the warm front depicted, which is the red line with the red half circles, you see a temperature of 60 degrees, and to the left or behind the front, you see a temperature of 85 degrees. It got warmer, so therefore that is a warm front. The dew point, that will change as well, just depending on what temperature and pressure the different air masses contain. And then the pressure is always going to fall and rise. Again, it will be lowest at the front itself, right, where the trough of low pressure exists. And the wind will shift, usually 90 degrees, but always clockwise after that frontal passage. And that is also indicated by the station models. The station model to the right or to the east of the warm front is showing 60 degrees and a wind direction of southeast. And then behind the front, it gets warmer, showing 85 degrees, and the wind has shifted clockwise 90 degrees to a direction of southwest. The factors that influence the amount or the severity of that frontal weather are as follows: the amount of moisture overall, the degree of stability of the lifted air. The less stable that the air is, the more likely there is to be bad weather. The slope of the front, or the angle between those two contrasting air masses. The speed of the frontal movement, and the contrasts between the amount of temperature and moisture between the two air masses. So if there's a very large difference in temperature and moisture content between two air masses defining front, there will be more severe weather. Okay, so the properties used to locate and classify fronts are temperature, dew point, winds, and pressure. The parameters of an air mass that are generally uniform across a horizontal plane are temperature and moisture. Location would be the third element necessary to completely name an air mass. Okay, moving on to cold fronts. We can talk about the conditions associated with it as well as squall lines. So a cold front, the overtaking air is colder and more dense than the warm air that existed beforehand. There's going to be frontal lifting, as we've learned previously about lifting methods. Because this cold air is heavier and more dense, it is going to lift the warm air up and out of the way as it starts to move in its direction, generally from west to east. There are typically cooler temperatures and clearing skies after the frontal passage, and it's a relatively narrow frontal zone, particularly when compared to the warm front. These normally move southeasterly at 20 knots, and therefore the wind out ahead will be parallel, coming from the southwest, and then the wind behind will shift 90 degrees clockwise to the northwest. Here's a video that shows the passage of a cold front, lifting the warm air up and out of the way that's ahead of it. Again, the winds shift during cold front passage from the southwest to the northwest. So you see the pressure is dropping. It's at its lowest at the frontal passage when the wind shift occurs, and then it rises back up to another higher pressure after the frontal passage. Squall lines are lines of severe thunderstorms. Their exact cause is unknown. If they do form in association with a cold front, they will form 50 to 300 miles ahead of the cold front, but they do sometimes form without the existence of a cold front. These contain severe hazards to aviation, and it would be ill-advised to fly in the vicinity of or especially through any of these squall lines. They are depicted as red dashed double dotted lines on surface analysis charts. There's the question. And again, it is a red dashed double dotted line. The slide is in need of updating. Here is a video depiction of a squall line. Looks just like the depiction of the cold front. And now there's a secondary line of thunderstorms within that 50 to 300 mile range in front of the cold front. All right, now we're going to talk about warm fronts and stationary fronts. A warm front happens when, as the weather moves from west to east, the temperatures increase or get warmer after the frontal passage. This is when the warm air is slowly advancing and replacing the cold air. Because of this, it has a very extensive forward slope, and the weather associated with these fronts typically extends ahead of the frontal surface boundary by approximately 500 to 700 nautical miles. With these fronts, we will typically see steady precipitation and reduced visibility ahead of the frontal passage, and they will move northeast at 15 knots. And since the wind is parallel out in front, the winds will be coming from initially the southeast and then shift 90 degrees clockwise to the southwest behind the front. Again, out in front of the frontal system of a warm front, it can reach 500 to 700 miles ahead of the surface position of the front. Here's a video depicting how that looks. You can see the stratiform type clouds, generally overcast, widespread, and steady precipitation associated with that large frontal zone of weather. Here's the video similar to what we saw previously with the cold front. This time it is showing the direction of movement of the warm front to the northeast and the wind shifting from southeast to southwest as we watch the pressure fall, be at its lowest during frontal passage, and then rise back up again. There's the pressure at the lowest point, winds shift, and pressure rises again. Stationary fronts are depicted as shown in the graphic to the right. It's going to be a series of alternating warm and cold front symbols that are also alternating in color, but on opposing sides. The symbols are different from the occluded front in that they alternate and oppose each other, where an occluded front not only is depicted as purple, but the cold and warm front symbols are on the same side of the line. The weather for these is going to be similar to a warm front, but it's usually less intense. So the stratiform type of clouds, steady precipitation, but less than you would expect to see with a typical warm front. These can align in any direction because they're not moving. So they do not move, but they can align north to south, east to west, or any direction in between. And the wind will be parallel on both sides of the front in this case, since there is no direction of movement. So what type of wind shift will you expect to find with the stationary front? 180 degrees since it's parallel on both sides. And this video is again just showing exactly that. Wind flowing parallel and in opposite directions on either side of a stationary front. Occluded fronts we're going to talk about next, and then also a little bit about inactive fronts and what those are. An occluded front is formed when a cold front overtakes a warm front. The symbology, as I mentioned previously, is purple, but using the same symbols as both the warm and cold front combined on the same side of the line. With an occluded front, as with all fronts, the pressure is going to fall, be at a minimum with frontal passage, and then rise back up. And in this case, the winds will shift 180 degrees from the southeast to the northwest, because an occluded front will always travel northeast, similar to the warm front. The most severe weather located with respect to the occluded front is going to be 300 miles to the north and 100 nautical miles to the south of the intersection where the warm and cold fronts become occluded. And here's a video showing how the cold front overtakes the warm front to become an occluded front. And if you'll notice the counterclockwise circulation that is typical to be seen when looking at a low pressure center and how the wind flows counterclockwise around it. With the occluded fronts, although they both travel in a northeasterly direction similar to a warm front, we can have two types, a cold type and a warm type, and depending on the type, the speed will be different. A cold type occlusion is going to move northeast at 20 knots, and a warm type will move northeast at 15 knots. The difference between these is going to be the overall change in temperature from beginning to end. starting off with relatively cool air and then finishing off with much colder air, you're experiencing a cold type occlusion, and those will typically move at 20 knots. The warm type occlusion, we started off with the coldest air and finished off with the relatively cool air. Those we will move at 15 knots to the northeast, and that's your warm type occlusion. And this is depicting obviously the actual occluded part of the front. If we went further south, we would get to the point where the weather that's being sandwiched in between is still in contact with the ground. Here's a visual depiction of it, starting off before the front becomes occluded, and then we'll see them mixed together. So at that point, they're occluded, and now the occlusion continues. This depicts a cold type occlusion. What kind of weather can be expected when flying through an occluded front? A combination of the two, weather associated with both cold and warm fronts. The most severe weather generally located with respect to an occluded front occurs 100 nautical miles to the south and 300 nautical miles to the north of the intersection. Inactive fronts are also known as dry fronts because they have no clouds or precipitation associated with them. The wind shift and the temperature change will still occur as with any other front. Because of that, it marks an area of potentially unfavorable flying conditions because we can still have wind shear, wind shift, turbulence, etc. associated with the front, even though there's no visual indications, clouds, or precipitation. In summary, we talked about air masses, what defines them, and how we name them. And we talked about cold fronts, warm fronts, occluded fronts, as well as stationary fronts and inactive fronts, which could be any of the previous. At what level above the surface do differences between two air masses forming a front become negligible? 15 to 20,000 feet AGL. Every front is located in a trough of low pressure. What kind of frontal system is depicted by this graphic? In this case, we're drawing our attention to the occluded front where the warm and cold front become mixed. Which frontal system has a more shallow slope, a cold front or a warm front? A warm front has the long, shallow slope. Lines of fast-moving thunderstorms are known as squall lines. How does the wind normally shift with the passage of a warm front? It shifts from southeast to southwest in a clockwise direction. What type of weather is usually associated with a stationary front? Similar to that of a warm front, but usually less intense.